Am I audible? Am I audible? So in our previous class, we have discussed about different aggregate properties, different tests on the aggregate particles, what are the different types of tests, how to find out different properties of the aggregate, and what are the batch mixing problem. Okay, now in this class, basically we will discuss about the cement as a pavement material. Now, if you ask that where that cement is used, so if you remember that there are two types of pavement, flexible pavement and rigid pavement. So generally in the rigid pavement case, you will have to use that cement concrete. Generally, PCC or plain cement concrete is used for that rigid pavement, but in some cases where the traffic would be higher or load would be higher, in such cases we can use that reinforcing cement concrete pavement. Now in that cement concrete pavement, if you use that plain PCC cement concrete also, there are different types of joints are there, and we will use some of the reinforcement in terms of double bars and tie bars, okay, to transfer the load from one pavement segment to other pavement segment. Now, if you go for the cement as a pavement material, so in that case, so maximum thing would be known to you. Now, you know that cement is the most important ingredient of cement concrete or cement mortar because that is a binding material. Now, in the flexible pavement case, just wait a minute. Somebody is asking me to share the link. Wait a minute. So cement is the most important parameter. So cement will act as a binding material for that cement concrete pavement. Now in case of flexible pavement, that binding material was bituminous material. Now there are some basic changes or basic property differences in cement concrete and bituminous concrete. Now what happens in the cement concrete, whenever water is added with that, in that case, that some chemical reaction or hydration process will be proceed. Okay, so in that case, that whole cement concrete mass that will act as a homogeneous mass, and the properties of that cement concrete mass will be different than the particular cement or particular aggregate particles. Now for the bituminous material, what happens, that bituminous material or bitumen will have a thin coating over the aggregate particles, and all the properties of the bitumen and aggregate will be remain intact. There will be no chemical procedure in the bonding between aggregate and the bitumen. So the most common cement, that is ordinary Portland cement, is generally used in that pavement construction. Now, if you go for the main ingredients of the cement, there are three ingredients: tricalcium silicate, dicalcium silicate, and tricalcium aluminate, and tetracalcium aluminiferrate is also there, and some miscellaneous compound. So, if you go for this is tricalcium silicate. It is referred as C3S, that is C2S, tricalcium aluminate, that is C3A, and tetracalcium aluminiferrate, that is C4AF. So these are the four ingredients which are constitute that maximum portion of the cement. Now, if you go for the different properties of the different types of cement, these are the different types of cement. Now, apart from this, there are another types which is called Portland pozzolana cement. Now, what are the pozzolanic materials? So, pozzolanic materials are that type of materials which doesn't exhibit any cementitious properties when they are separate, but whenever they are mixed with cement and added with water, in that case some cementitious properties would be generated in that chemical procedure. So that type of material is called pozzolanic material, like your fly hatch ash or rice husk ash, etc. So this type of pozzolanic materials will be grinded with fine modulus, or they will be grinded into dust, and they will added with the cement. So basically mixing with the pozzolanic material, that is a cost cutting procedure, and as well as it will give a considerable strength to the cement. Now for the pavement construction, this is another important thing. Generally 43 grit cements are used. Now there are different properties of the cement. So these are the properties. First one is fineness. So this is related to grain size and specific surface. Fineness is a desirable feature because it is related to the intensity of hydration and strength gain. Okay, if that cement is not fine, in that case, that hydration procedure will not take place. It will not be in full swing, and it will affect the strength of the cement. The sieve analysis is the simplest thing to know that what is the fineness of the cement, and in this category there is one particular parameter which is called fineness modulus, to know the fineness of the cement, or to understand that what is the fineness characteristics of the cement. So generally for the dry cement, if you sieve it through 90 micron IS sieve, then that residual should not be more than 10%. And for the OPC, that is ordinary Portland cement, that residual should not be 5%. Then another important thing is setting time. You know, all of you know that there are two types of setting time: initial setting time and final setting time. Now, workable cement mortar paste using a desirable water cement ratio is prepared, and the time taken for the paste to harden is noted. Now, all of you know about the test of the setting time. Now, the main important thing is why we need to know that setting time of the cement. Okay, what is the uses of the initial setting time and final setting time of the cement? So basically, if you test maximum cement, in that case, the initial setting time would be around 30 minutes. So basically, it indicates that within 30 minutes or within half an hour, you have to place the cement in the appropriate position. Okay. Otherwise, it will get hardened and you will not get adequate strength of that cement. So therefore, initial setting time is very important, because by that initial setting time, by knowing that initial setting time, you know exactly how much time you have to place the cement in a appropriate position. Now another thing is final setting time. So generally final setting time is 10 hours. So final setting time is the time when the cement get hardens, or uh, uh, when it is sorry, when it can take some strength. Okay, when it has some strength, that is your final setting time. So for the final setting time of the OPC cement is 10 hours. So before the 10 hours, that cement would be partially very weak. So you have to take consideration about all this fact when you are placing the cement. So basically, the final setting time is the time required for the concrete to harden sufficiently to attain the shape of the mold in which it is poured. So by this time, primary chemical reactions are completed. So all the chemical reaction, that is hydration process, has already been completed. Now this is important for the removal of formwork. Removal of formwork means, suppose you are constructing one column or constructing one beam, or like that. So in that case, so to construct beam or column, you have to build some formwork. Formwork means, in terms of wooden structure or any other steel structure, you will enclose a portion of that beam or column where reinforcement is there. So you put that reinforcement, and over there you will put that cement and aggregate mixer. So after some time you have to remove that formwork, or you have to remove that cover. Okay, so basically when you want to remove, that indicates that by the final setting time. So whenever the final setting time overs, in that case you can remove the formwork. Then another test is there, soundness test. Now soundness test is conducted by Le Chatelier apparatus. So basically soundness test is important to know how much volumetric changes may happen in the cement. So why it is important? Suppose you have put your cement aggregate mix in a certain enclosed structure. So after that, if that volumetric changes are huge, in that case it will create some crack in the enclosed portion. So therefore you need to know what is the volumetric changes or possible volumetric changes of the cement particle you are using. Then another thing is chemical composition. So basically, chemical composition is it is found out by a parameter. It is called that lime saturation factor. So basically, lime saturation factor of a cement is the ratio of calcium oxide to the other three main oxides present in it. Okay, so there are different types of oxide present in the cement. So that lime saturation factor is the ratio of calcium oxide to the silicon dioxide, alumina, and ferric oxide. So in general, it should be in the range of 0.66 to 1.02 as per IS 269. So if you go through the note for all the test, I have mentioned the codes. So if you want to have a brief knowledge about all these tests, you can go in this IS specification. Then strength of the cement is found out by the cube test. So all of you know about this, that cube test. Generally 3 days, 7 days and 28 days cubes are tested after sufficient curing. Now another important thing is admixture for the cement concrete. So for the cement, most important factor is water cement ratio. Water cement ratio means by which ratio we will add water to that cement material, cementitious material, so that it can attain a sufficient strength. Now why water is added? Because water will enable the hydration process, and for the hydration process lots of water quantity is required. Now the thing is, whenever you added up the water, the strength of the cement is building up, but as soon as you will increase the particular amount of the water, then from the required amount, in that case that strength will decrease. Okay, so basically in the cement mix, the main strength is coming from the water cement ratio. So water cement ratio is the deciding factor about the strength of the cement. So if water cement ratio increases, in that case strength will decrease. Now the thing is, you cannot use a very less amount of that water cement ratio, very less amount of the water. Why? Because if you add very less amount of the water than required, in that case it will create a honeycomb structure, and the hydration procedure will not be in full, and therefore the total strength of the cement will not be there. Okay, and in that case the structure will be not as strong as which it should be. Okay, therefore sufficient quantity of the water need to be added over there. Now another thing, as soon as you increase the water cement ratio, or you increase the quantity of the water in the mix, in that case that workability of that particle or workability of that mass will increase. So if you go for the workability, what is workability? Workability is the ease with which you can mix, place and transport a particular cementitious material or cement mix, cement concrete mix. So for the workability, you need to increase the water cement ratio, but for the strength, you need to decrease the water cement ratio. Now, for the high strength structures where the strength of that concrete particle is required is higher, in that case, you have to uh, maintain the water cement ratio. You need to add the minimum water cement ratio to make up that hydration procedure. Okay, but in doing so, the workability of that particle or workability of that mass will be get reduced. So in that case, what you can do? In that case, another thing is there. One specially chemical particle is there, which are called admixtures. Okay, so there are different type of admixtures. So the particular, in particular case, whatever I have told you like right now, in particular case, you add up some admixtures with that cement concrete mix, so as to increase the workability, but to maintain a minimum water cement ratio. So whenever you added that admixtures, in that case what will happen, that that workability of that mass will increase, but the water cement ratio will remain same. So in that case you will get sufficient strength of that cement concrete mix, but as well as the workability of that mixer would also be higher. So apart from this, there are other types of admixtures. So some of the admixtures are, first one is retardants. So basically it increase the setting time of cement concrete. So it will increase the initial setting time of the cement. Now, why it is important to increase the initial setting time? Suppose you are constructing a particular portion of the building in some area where no sufficient places is there to mix that cement and aggregate. Okay. Now in that case, you will have another area where you will mix all these things, and one particular vehicle is there through which you will transport that cement aggregate mix to your particular location. Okay, so in that case, if you transport it in that particular location, and if that location is at a distance of suppose like 40 minutes or 50 minutes from that particular your site location, in that case you need to slow down that hydration procedure. Okay, you need to increase that setting time of the cement. So basically, in that case, you will use retardants. Okay, in that case, you will use retardants. So by doing so, the setting time of the cement will increase, and you can easily transport that cementous material to your site location and use that for your construction. Another type of thing is there that is called admixtures is there that is called accelerators, and accelerate the hydration process for the rapid strength gain within a short span of time. Suppose there is some road construction is going on, suppose rigid pavement. In that case, it is needed, or some maintenance work is going on over the road. Now it is needed to so that that cementous material, whichever you have put over that your broken portion, it got rapidly hardened so that it can be used as soon as possible. Otherwise, the traffic would be hampered. In such case, you need accelerators so as to increase the rate of the hydration so that the cementous material got hardened very fast. Then plasticizers and super plasticizers. So plasticizers and super plasticizers are used to increase the workability of the concrete and reduce the water content needs and reduce the heat of hydration. Okay, so these are the plasticizers and super plasticizers. So basically these are the things which I have given some examples, like what you have to do whenever your water cement ratio need to be reduced but your workability should be increased. So in that case you can use plasticizers and super plasticizers. Now, another important admixture is air entraining agents. So in that case, this air entraining agents will also improve the workability and increase the resistance to forced action. Forced action means suppose you are building a particular area which is uh, a cold area. Okay, where temperature is suppose 2 degree 3 degree or below that. In that case you need some air entraining agents to improve the workability and to increase the resistance of that particular mix against that lower temperature or against that freezing temperature, or it is called frost action. Then another admixture is pigments. So pigments is generally used to color the cement particle. So it will impart color to the cement concrete mix for aesthetic. So apart from this, there are other admixtures also like fly ash, blast furnace slag, pond ash, rice husk ash, calcinite clay, etc. So basically these type of admixtures are used to reduce the quantity of the cement in the mix, and it will be very economical to use such type of material in replacement of the cement. So there are basically different research works which is going on and which are already available. So in that research work, they have mentioned that how much different types of admixture, this type of admixture can be replaced in the cement mass so that sufficient strength could be achieved. Now coming to the properties of the cement concrete. So there are different properties of the cement concrete. First one is workability. So what is workability? I have already discussed. So generally slump tests are conducted to find out the workability. Beside the slump test, there are other tests also like compaction factor test. Okay, so slump ranges from 25 to 125 millimeter. That are the range of the slump, and the prescribed compaction factor values are of the order of 0.75 to 0.80 for your road construction. Okay, I will repeat again about that workability. So basically, workability is the ease or how easily you can mix cement with your aggregate, your sand and water, and how easily you can mix all these particles together, how easily you can place that particular amount in a particular construction, and how easily you can transport that. Okay, so in simple word, workability means how workable is that particular aggregate, cement aggregate mixes. How workable means how much work can be done with that. Okay, how easily you can uh, do all these steps with a particular cement concrete mix. Okay, so basically that is the ease of placement, ease of mixing, and ease of transporting that aggregate and cement mix from one place to another. So basically that is the workability. So let me give one example. In that case, it would be clear to you. Suppose for a slab construction, or suppose for a pile construction where needed workability is very high. So in that case, suppose for a pile construction, what will happen, you will dig some hole in the ground. After that, you will put some reinforcement over there, and there will be some enclosure, and through that enclosure you will push some cement aggregate mix through that hole. Okay, now in that case, you have to pump that mix in the hole, because the depth of the hole would be like 30 meter or 30 feet or 40 feet, like that. So in that case, pumping is very much required. Now, if the water quantity of that mass is very less, okay, in that case you cannot pump it. It is not possible to pump that particular material. Okay, now if it has sufficient quantity of the water, in that case you can easily pump it through that hole or through that enclosed portion. So basically that easiness of placing that mix into a particular enclosure or into a particular construction site, that is basically workability. Okay, is it clear now what is workability?
Yes, sir.
Okay, so basically workability increase with the adding up of the water, and it decrease with the decreased quantity or less quantity of water.
Sir,
Yes.
sir, can you repeat the Poisson ratio? Can you define the Poisson ratio, sir?
Okay, so Poisson ratio is basically lateral strain by longitudinal strain. That is basically Poisson ratio. Now, in case of that cement particle, if you go for the practically, that what that Poisson ratio indicates, in that case, it indicates how much stress it can take, okay, without changes in that behavior, without changes in that in its physical properties. Okay, so basically that is the ratio of strains. So in that case, strain is nothing but your uh, changes length with respect to the original length. Okay, that is volumetric changes. So a Poisson ratio indicates how much volumetric changes would be happen if there is some external stresses. Is it clear?
Okay, sir. Thank you.
Okay. Then coming to the concrete pavements. So due to their high bearing capacity and increased stiffness, stiffness means stiffness is generally defined as K, and you will find this stiffness modulus or stiffness values from plate load tests. Stiffness means that is similar as your Poisson ratio indicates that how stiff it is, how much volumetric changes will be happening whenever you apply some external stresses over it. So these are the example where concrete pavements are used. Generally, parking aprons, taxiways, and runways. Taxiways are basically these are used in the airport and runway takeoff areas. They are also you will use that rigid pavement. Then parking grounds for vehicle of heavy weight, then heavy duty industrial floors. So basically these are some of the example. I'm not going through all of these things. So these are the different examples where you can use your rigid pavement. And if you go for the difference between flexible and rigid pavement, the design life of rigid pavement is generally higher than the flexible pavement, and it can carry maximum load, more load than the flexible pavement. So in that case also you use the rigid pavement based on the loading conditions of that particular area. Now, beside this, there are other uses of the cement as a pavement material. So one use is soil stabilization with cement, cement and hydrated lime, or cement and fly ash. Soil stabilization means the base of your pavement is your subgrade soil. Okay, so subgrade soil is basically that lower portion of your pavement. So in that case, if the soil doesn't have adequate strength, in that case, it cannot take the stresses coming from the vehicle load. Okay, so therefore you need to stabilize the soil, or suppose the soil is in loose state, in that case you need to stabilize the soil so that it can carry maximum load. So in such cases, your cement, either you can use the cement or hydrated lime. That it hydrated lime is CaOH, okay, calcium hydroxide, or cement or fly ash can be used. Okay, so in some cases, cement slurry can be used. Cement slurry means cement will mixing up with high quantity of water, and it will and you will pump this mixer into your soil so that sufficient strength of the soil can be generated. Okay, this type of things are called soil stabilization. That how you will stabilize a unstable soil or a disturbed soil. So if you increase the stability of that particle, stability of the soil, in that case, what will happen? In that case, the required thickness of the pavement material, upper material, would be lower, and it will be very much economical. So basically that is written over here. In all these cases, the durability of the stabilized material against environmental impact is substantially higher than that of the non-stabilized material. So in this way, considerable savings are achieved due to the reduced thickness of the road pavements. So if the soil is disturbed, if the soil is loose, or if they are very much weak, in that case the severe value of that soil particle would be very less, and if the severe value is very less, in that case the required thickness of the pavement should be higher to accommodate that loose soil. Okay, so in such case, if you increase the stability of the soil, it will enhance the strength of the soil particles, and therefore the required thickness of that upper layer would be lower. Then recycling of the pavements with the cement. So basically it is a recent successful evolution. So for this restorations and or upgrade or warm out from the traffic road surface. Suppose in a traffic road there are, or in a particular road there are some patches or there are some potholes. In that case, uh, you can recover this pothole using that pavement, cement concrete pavement, and it will affect with the least possible environmental strain and very low cost. So how basically this has been found out? What is the main thing about that recycling of pavements with the cement? So basically what happens, suppose there is some potholes or some damages of the existing road surface in a particular area. So if the depth of that pothole is very much higher, in that case you can put some previously used cement concrete, hardened cement concrete mix over there, like as aggregate. So you broke down that pieces into small particles and can use in that potholes to fill it up. After that, you can use some cement concrete mix, freshly cement concrete mix to seal off that particular potholes. So in that case, you are recycling that already waste of the construction particles over that particular place. So this is another use of that cement concrete pavements. And another important thing is pervious concrete. So in the pervious concrete, what happens? It that water can easily pass through that pervious concrete. Okay, it would be perforated type. Okay, so whenever you will put some water over it, in that case, that all the water quantity will be passed through it and go in the underneath portion. So in the pervious concrete, whenever you are designing a pervious concrete, so in that case, you will not use any finer material like sand or dust particle. You will not use in that case. Okay, so in that case, if you will not use any sand particles, that there would be so much gap or so much voids in that particular aggregate mix, and it will act as a perforated or as a channel through which water will pass. Now, what are the uses of the pervious concrete? Suppose a parking lot is there. Okay, now you know there is in many places there is a problem of the groundwater. Okay, so groundwater is reducing day by day. So in that case, if all these things are built up with the concrete, in that case rainwater cannot penetrate through the ground, and it cannot increase that groundwater level in a particular area. All this rainwater will be get wasted. So in such cases, if for the parking lot or for your some ground, you can, whenever you need to put some pavement or you need to put some construction over there, you can go for the perforated one. So for the perforated one, what will happen? All the rainwater can easily penetrate through it, and it will increase or it can recharge the groundwater. So basically that is the uses of the pervious concrete, and that is very much environment friendly because it enhances that groundwater recharge for a particular area. So see, these are the pervious concrete. Whenever water is added, all this water can penetrate through this pervious concrete. So in industrial application, pervious concrete has been used successfully for the construction of the floors in greenhouse and industrial dairy farms. So there are different uses of that pervious concrete, and your final year batch, that is your senior batch, one of the groups are also working on this pervious concrete. They built some pervious concrete block sections, and I don't know whether they have tested that material or not, but they have finished that work. So from the technical point of view, the mixed design of the pervious concrete includes cement, limited amounts of water with water cement ratio varying from 0.35 to 0.45, chemical additives, and chemical additives means some admixtures, and aggregate having a very narrow gradation. Narrow gradation means that would be either gap graded and complete absence of sand. There would be no sand. Generally, in the cement aggregate mix, that mixture would be cement, aggregate, and sand, but no sand would be there, and also that aggregate particles, that gradation of that aggregate particles will not be well graded. That would be poorly graded particles. So as a result, concrete with a compressive strength of 35 MPa is produced having a void content of 15 to 30%. So here void content would be higher. So it would be a continuous porous structure as water cement ratio is lesser, and there would be voids in that aggregate mass. So that would be a porous structures, and through this porous structure water can pass through it, and drainage rate of the pervious concrete would be 700 liter per minute per meter square. So this is all about today's class. Now I'm taking the attendance. After that you can leave. Okay, you can leave.